Let us see question number 31. Integration of sin square x cos square x by sin power 5x plus cos cube x sin square x plus sin cube x cos square x plus cos power 5x whole square. So let us take cos power 5x common from the denominator. Hence the problem will become integration of tan square x into secant power 6x divided by tan power 5x plus tan square x plus tan cube x plus 1 whole square. This is nothing but integration of tan square x into 1 plus tan square x whole cube divided by tan cube x plus 1 whole square into 1 plus tan square x whole square dx. That is equal to integration of tan square x divided by tan cube x plus 1 whole square into 1 plus tan square x dx. Now the problem has come to the simplest form. Let 1 by tan cube x plus 1 is equal to t, then you will get the integration value will become after simplification minus 1 by 3 into 1 plus tan cube x plus c. So hence option 1 is correct answer. See question number 32. The given hyperbola is x square by 9 minus y square by 36 is equal to 1. So that will be like this. So from a point 0 comma 3, the point 0 comma 3, that is t, two tangents are drawn which are tangent to the parabola hyperbola at p and q. So we need the area of triangle TPQ. We need the area of triangle TPQ. PQ is chord of contact of 0 comma 3. So PQ is chord of contact of 0 comma 3. Therefore equation of PQ is x into 0 by 9 minus y into 3 by 36 is equal to 1. That implies y is equal to minus 12. That implies y is equal to minus 12. Therefore x square by 9 minus 144 by 36 is equal to 1. From there you will get x square by 9 is equal to 5. So x is equal to plus or minus root 45. X is equal to plus or minus root 45. Therefore area of triangle TPQ is equal to half into height. This length is minus 12. So half into 15 into 2 root 45. Half into 15 into 2 root 45, that is nothing but 45 root 5. Hence option 4 is correct answer. Hence option 4 is the correct answer. So let us see question number 33. Y square equal to 16x is the given parabola. There is a point P 16 comma 16 from which tangent and normal are drawn to the parabola which are intersecting at A and B, and the midpoint of A and B is C, or else the circumcenter of triangle APB is C, and we want the tan angle of CPB. Hence let us draw a line parallel to x axis or axis of the parabola. This length and this length are always equal. So this angle is theta, and this angle is also theta, and this angle is also theta. Now out of 90, theta has gone here. So this is 90 minus theta. As this is 90 minus theta, we know this is minus 80 square comma 0 A point, B point is 2A plus 80 square comma 0. Therefore, this is minus 16 comma 0. So, slope of AB is equal to tan theta, that is 16 by 32, that is half. Therefore, tan angle of CPB from the triangle CPB is tan of 90 minus theta. Tan of 90 minus theta is cot theta, that is nothing but 1 by tan theta, that is 2. Or else what we will do is, we know the equation of the tangents and normal at any point in parameter t, where t is 2, yt is equal to x plus at square and y plus xt is equal to 2at plus at cube. Using that also we can find the slopes of CP and BP, and we can find the tan angle included between them. So therefore, if we go through the options which are given to us, the fourth option is 1 by 2. Therefore, tan CPB is equal to 1 by 2. Option 4 is correct. So, fourth option is the correct answer. Let us see question number 34. U is a vector coplanar with A and B, and U is perpendicular to A. So, any vector coplanar with A and B perpendicular to A. So, a vector is coplanar with two vectors A and B perpendicular to A. So, let us consider A cross B. A cross B is a vector perpendicular to the plane. Now, you consider A cross B. A cross B or minus A cross B, both of them will fall into the plane. Therefore, K into A cross B. K into A cross B is any vector coplanar with A and B and perpendicular to A. So, let us assume that U is equal to K into A cross B, that is nothing but K into A dot B into A bar minus A dot A into B bar. On simplification, you get K is equal to minus 1. On simplification, you get K is equal to minus 1. So, U is equal to minus of A cross B, that is minus of A dot B into A bar plus A dot A into B bar. You know the values of A bar, B bar, A dot A and B dot B. Put all of them back in the given thing, then you will get mod U square is equal to 336. Hence, choice 4 or option 4. Choice 4 or option 4 is the correct answer for 34th one. Let us see problem number 35. Let us consider the equation x square minus x plus 1 equal to 0, which has two distinct roots alpha beta, which are complex numbers. This can be written as x square plus minus x plus 1 is equal to 0, where minus x is equal to t. Then it will become t square plus t plus 1 equal to 0, for which all of you know that omega and omega square are the roots. That implies minus x is equal to omega or omega square. That implies x is equal to minus omega and minus omega square. Therefore, alpha power 101 plus beta power 107 is equal to minus omega whole power 101 plus minus omega square whole power 107, that is nothing but 1. Therefore, option 2 is the correct answer for this question.
Let's do number 36. That's a question that connects composition of function to some extent in the area. So that says that g of x is cos of x square, f of x is root of x. So we know that y equal to g operation fx, g composed with fx, that equals cos of x. Now 18x square minus 9 pi x plus pi square equal to 0 has roots alpha and beta, alpha less than beta. We can find the roots. We can write x square minus pi over 2x plus pi square by 18, and the roots happens to be pi by 3 and pi over 6. So now your area that happens to be between pi over 6 and pi over 3 So that curve is y equal to cos x, and its integral cos x pi over 6 to pi over 3. That's your area. That happens to be sine of x pi over 6 to pi over 3, and that simplifies to root 3 over 2 minus 1 over 2. So that is 1 over 2 root of 3 minus 1. And so 36, choice 4 is the correct choice. Let's do number 37. The question asks you to find the sum of the coefficients of all odd degree terms in the expansion of x plus root x cube minus 1 whole to the power 5 plus x minus root x cube minus 1 whole to the power 5. So the problem asks us to calculate the sum of the coefficients of all odd degree terms in the expansion. This expansion is like a plus b whole to the power 5 plus a minus b whole to the power 5, and that gives you 2 a to the power 5 plus 5c2 a cube b square plus 5c4 a b to the power 4. When we write a as x and b as square root of x cube minus 1, this expression takes the form 2 x to the power 5 plus 10 x cube minus 1 and plus 5 x cube minus 1 whole square. When simplified, this gives you twice of x5. So if you want the coefficients, you will get 2 times x5 will contribute 1, then here you will get minus 10. This 10 comes from x cube, then you will get plus 5 and then plus 5. 1 plus 5, that will come from x7 and other will come from x. And so your answer happens to be 2. So our answer is 37, our answer is 3, option number 3, and the answer happens to be 2. Let's do number 38. It's a question about number of terms in AP. So the question reads that let A1, A2, A3 till A49 be in AP such that sigma A4k plus 1, where k ranges from 0 to 12, is given to be 416, and A9 plus A43, that happens to be 66. The question asks you to find m, where you have a1 squared plus a2 squared till a17 squared equals 140 times m. So it's a basic question. We just have to express everything in terms of a1 and d and solve the set of equations, and from there we can find the answer. So let's do it. The first condition, a4k plus 1, that reads as, this is a1 plus a5 all the way to a49 is given to be 416. So we have 13 terms in all. So we have 13 over 2 times a1 plus a49 equals 416. When I simplify this a49 as a1 plus 48d, this will become 13 over 2 a1 plus 48d is 416, and that simplifies to a1 plus 24d is 32. This is our equation 1. So we have got one relation between a1 and d. The second condition, a9 plus a43, I can again simplify this as a1 plus 8d plus a1 plus 42d equals 66. and that gives you A1 plus 25D is 33. Now use 1 and 2 to solve for A1 and D, which is pretty simple, and that leads us to A1 equals 8 and D1 equals 1. So we have now 8 squared plus 9 squared till 24 squared. This sum I can calculate by 1 squared plus 2 squared plus going till 24 squared and minus 1 squared plus 2 squared plus 7 squared. It is sum of squares of first 24 terms, and the next summand is the sum of squares of first 7 terms, so that you can calculate as 24 into 25 into 49 over 6 minus 7 into 8 times 15 over 6, and that simplifies to 140 into 34, and so our m turns out to be 34. And so the answer to the number 38 is option 2, that is 34. Number 39, this question concerns the standard deviation of some items. So let's write the data. So it says sigma of xi minus 9, where I ranges from 1 to 9 equals xi minus 5, that is 9, and sigma xi minus 5 whole square I from 1 till 9 equals 45. Let's discuss this fact, or let's make sure the fact that standard deviation does not depend on the change of origin. So it remains invariant under the change of origin. Let's apply this idea and work with xi minus 5. So let's write yi is xi minus 5. We are given sigma yi is 9 and sigma y squared is 45. The standard deviation happens to be root of sigma yi squared over 9 minus sigma yi over 9 whole square. This n happens to be 9 here, so now we know this answer is 45 upon 9 minus 5 upon 5 whole square. That gives you root of 5 minus 1, so that's root 4. That happens to be 2. So the answer happens to be 2, and the choice is also option number 2. So option number 2 is correct. So it was number 39. The correct choice is number 2. Number 40 concerns about a tower. So it's a height and distance problem. Let's make the diagram of the problem. It says that PQR, so PQR, so let's draw like this, P, Q, and R. This is triangle, isosceles triangle. So given PQ equals 200 and PR also equals 200. So that's number 40. So there is a tower at the midpoint of QR, and you have got this tower, let's write as Mn. This tower subtends an angle of 30 degree at Q as well as at R, and as P, that tower subtends an angle of 45. We are to calculate the height of the tower. So let's say that your height of the tower equals h. So Nm equals h. Let's take the triangle N, M, and Q. This angle is 30 degree. This height is h. So this QM, that happens to be h root 3, because tan 30 is 1 over root 3. Let's think of another triangle, a little oblique one, that is N, that is M, and this time we are taking P. So this is N, M, and P. So this is the plane NMP. Now this is 90 degree, this is 45, this is H, so this happens to be H. Now let's take the original triangle, that is P and Q and R as the triangle is isosceles, we know that this height, that is PM, M is the midpoint, so PM is the altitude, and so this is your length given, that MR happens to be h root 3, same as m cube, and MP happens to be h, and so we have the right angle triangle PMR, which gives h square plus h root 3 square equals 200 square. You get 4h square is 200 square, and that gives h equals 100. So the height of the tower in meter equals 100. That's choice number 4. So option 4 is the correct choice for it. Number 41, that's really interesting question. It concerns two sets A and B, and you have a couple of choices connecting A and B, like A is a subset of B, or intersection is phi, or something like that. So let's plot A. So first of all, let's work with A minus 6 and B minus 5 instead of A and B, because that's pretty simple. It's like change of origin. We write A minus 6 is U, this is V, so set B, that becomes U square upon 9 plus V square upon 4 less than equal to 1. That's an ellipse. So that's an ellipse in the UV plane, which we can plot as this is U, this is V, so that's minus 3 comma 0, that's 3 comma 0, this is 0 comma minus 2, and that is 0 comma 2. That's our B. So our B is the set of all points that are interior to the ellipse or on the boundary. Let's think of A. Now in terms of U and V, our A becomes modulus of U plus 1 less than 1 and modulus of V less than 1. This further simplifies to minus 2 less than U less than 0 and minus 1 less than V less than 1. So in the UV plane, that happens to be a square of side lengths 2, and as we see, we can plot it like this way, that this is one square, that we can see entirely inside. So this line is, say, V equal to 1, that is V equal to minus 1, and this is U equal to 0, and that's U equal to minus 2, and all the area of B, I'm sorry, it's A. The area A, or the region A, is nothing but the set of all points that are interior to this square. That does not matter, because as this A is completely inside the ellipse, so we have the option that A is a subset of B, and so the choice 1 is correct choice. Now let's go over to number 42. It's a question about counting problem. It's pretty simple, should not be difficult. So let's do number 42. You have got 6 different novels. So I say 6 different novels, and you have got 3 different dictionaries. You are supposed to choose 4 out of 6, and you are supposed to choose 1 out of 3. So the job, this can be done in 6C 4 wage. This can be done in 3C 1 wage. Now the question says that they are to be arranged in a row such that dictionary is always in the middle. So out of 5 objects, dictionary is always in the middle. You have left with only 1, 2, 3, 4 places and 4 objects, and so this arrangement can be done in factorial 4 wage. Now just multiply all of the 3, you get 6C4 times 3C1 times 4 factorial, and that happens to be 6C2 times 3C1 times factorial 4. So that is 15, then 3, and then 24, and that happens to be 1080. And so the choice number 4 that says at least 1000 happens to be correct. So it's choice 4. Number 43. It's one of the most beautiful questions, and no doubt it has troubled many students. So let's do it in detail. So number 43. Let's plot the graph of g of x is x minus 1 over x. Of course, they have excluded that x is element of r, minus 0 and minus 1 and 1. These 3 points are not wanted. So the graph will look like this is minus 1, this is plus 1. So the graph looks like this, and then it looks like this. So let me write minus 1 here. So this is the approximate graph of y equal to x minus 1 over x. As you can see that this point minus 1 and 1 we don't want. That does not matter much. So this x minus 1 by x takes all the values except that 0. Now to answer the question, let's write h of x. H of x is f of x over g of x. I choose to work with x minus 1 over x rather than x because that's simple. And so let's write this x minus 1 over x as t. So we have got h of t is t square plus 2 over 2 over t, and so that's t plus 2 over t. We know t is element of minus infinity to infinity and 0 taken out from that, so that's minus 0. If t belongs to 0 comma infinity, we can apply AMGM and write t plus 2 over t greater than equal to 2 times t times 2 over 2, so that equals 2 root 2. The most important point is that this equality is indeed attained for t equal to root 2 because x minus 1 over x does indeed take this value. After that, we can claim that this is a candidate for local minima, but let's check what our calculus says. We have got h of t, so h prime t is 1 minus 2 over t square for t element of 0 till infinity. And so if I draw the sign scheme, it's like 0, it's like 0, and then root 2, and then infinity. After root 2 onwards, it's plus, then negative. So it is decreasing here and increasing here. And so the point root 2 happens to be a point of local minima. And we can say that 2 root 2 is a local minimum, and the answer happens to be choice number 3. Choice number 3. Number 44. This concerns the limit, and the function is defined in terms of greatest integer function. So it asks you to calculate limit. It's number 44. So limit x tend to 0 plus x times integral part of 1 over x plus 2 over x all the way to 15 over x. Let's try to bound this function from above and below. So we use k over x. We use k over x, integer part less than equal to k over x, and left side is k over x minus 1. Let's sum it all. Let's sum it all from k equals 1 to k equals 15. That gives you k over x sigma k equal to 1 to 15, and sigma k over x k equal to 1 to 15 minus 15. Let's multiply throughout by x. That gives you sigma x sigma k equal to 1 to 15 k over x. that is sigma k equal to 1 to 15, that is k minus 15x, sigma k equal to 1 to 15. When you pass to limit, that's limit x tend to 0, on both sides the limit happens to be the sum of first 15 numbers, and that happens to be 1 plus 2 plus 15. So that is 15 into 16 over 2, that is 120. And so by what we know as sandwich principle, or it is called also as a squeeze play theorem, we get the result as 120. So the limit happens to be 120 and the answer happens to be 2. Let's do number 45. It's a question about different integral. So let's write number 45. You want to evaluate this, let's call it I. We want I equal to minus pi by 2 to pi by 2 sine square x over 1 plus 2 to the power x dx. So we can use a property, quite famous property, that reads that you can change x to a plus b minus x in a different integral where a and b are lower and upper limits respectively. In this case, a plus b happens to be 0, and so I takes the much simpler form. It's like changing x to minus x, that gives minus pi by 2 to pi by 2 sine square x over 1 plus 2 to the power minus x dx. Let's add them up. So that gives you 2I equals minus pi by 2 to pi by 2 sine square x comes out to be common. It is 1 over 1 plus 2 to the power x plus 1 over 1 plus 2 to the power minus x dx. That pretty much simplifies, and that equals minus pi by 2 to pi by 2 sine square x dx, because that becomes 1. This becomes 1. Indeed, you have got 1 over 1 plus a plus 1 over 1 plus 1 by a equals 1. Of course, a is not 0. You got like this. We can write 2i's of 0 to pi by 2 sine over x. That equals 2I equals 2 into pi over 4, and so I happens to be pi over 4. And so the choice that is correct is number 3. 45, number 3. 46, it's a question about probability, and we can do it best by drawing a diagram. It tells a bag contains 6 balls, 4 red balls and 6 black balls. What you do is that you are drawing a ball randomly. Let's say that random ball is red. So you are drawing one red ball and replacing it with 2 additional balls of the same color along with this ball also. So that happens to be now, you return it, that becomes 6R and 6B. If you choose to draw a black ball, then now it is 4 red and 8 black. And now the question says that you want to draw one more ball. So what is the probability of drawing a red ball? So this one red ball, the probability of drawing this red ball is 1 over 2 because they are both equal numbers. This is 1, this is 4 over 4 plus 8, that simplifies to 1 over 3. The probability of drawing this red ball is 4 over 4 plus 6, that is 10, that's 2 over 5, and so this is 3 over 5. Now we're using a principle, and I will state it like that the requested probability is the sum of product of probabilities along all possible paths. And so we have got 2 possible paths. So we find that probability of the ball being red is 2 over 5 times 1 over 2 and plus 3 over 5 times 1 over 3. That gives 1 over 5 plus 1 over 5. That's 2 over 5. And that's our choice number 1. So 46, choice number 1. 47. This question relates the projection of segments joining some points on the plane. It's best done geometrically. That's the simplest solution we can have. So that's number 47. Observe that that plane happens to be pi, that's x plus y plus z minus 7 equals 0. We have got the points 5, minus 1, 4. So pi at 5 minus 1, 4, that gives you 5 minus 1 plus 4 minus 7. That's 5 plus 4, 9, and minus 8, so that's 1. And pi at 4, minus 1, 3 is 4 minus 1 plus 3 minus 7. And that is 4 plus 3, 7, so that is minus 1. So just observe that these 2 points are on the opposite side of the plane, because one is positive, one is negative. So let's write this point A and the point B as 4 minus 1, 3. So we have A somewhere here. Let's call 5 minus 1, 4. We have got B somewhere here. We have got B somewhere here. That is B. That is AM, and that's BN. We also know the length AM because AM turns out to be 1 over root 3, and same for BN. So these lengths AM and BN are equal, and the triangle AM, let's call it X, triangle AMX and BNX, these 2 triangles are congruent. So we have got this AX as 1 over root 2 because AB happens to be root 2. B was 4 minus 1, 3. So AB is root of 1 squared plus 1 squared, so that's root 2. So your AX happens to be 1 over root 2. You have got AM, that happens to be 1 over root 3. So MX happens to be root of 1 over 2 minus 1 over 3. That's root of 1 over 6. And MN is just twice of MX. That's twice over root 6. And that happens to be root of 2 over 3. And so the choice 3 is correct. 3 is the correct choice for that. Number 48, it's a trig equation, and you have to find the sum of all solutions. The problem reads 8 cos x times cos of pi over 6 plus x times cos of pi over 6 minus x minus half, and that equals 1. Let's try to simplify that. This is cos of a plus b into cos of a minus b, and that equals cos square a minus sin square b. So it takes the form 8 cos x minus into cos square pi over 6 minus sin square x minus half is 1. Seeing cos x terms, let's try to change sin to cos. So you get 8 cos x cos square pi over 6. So that is cos pi by 6. That is root 3 by 2, so 3 over 4 minus 1 plus cos square x minus half is 1. It simplifies to 4 cos cube x minus 3 cos x is 1 over 2, and that's precisely cos of 3x. So we are getting cos of 3x equals half. Because x belongs to 0 to pi, we have 3x belongs to 0 to 3 pi, and that gives 3x equals pi over 3 or 5 over 3 or 7 pi over 3. Let's sum all of them. So we get 3 sigma x, all values of x, that equals 7 plus 5 plus 1, 13 pi over 3. And so sigma x is 13 pi over 9. And so the k happens to be 13 over 9. So that's choice 1.
Question 49. So a straight line through a fixed point
2 3 intersects coordinate axis at distinct points P, Q. O is origin and rectangle O, P, R, Q is completed. Then the locus of R is, and here is a diagram representing the given data. O is origin, the point where the straight line cuts is P, x axis, and y axis at Q, and join PQ. The rectangle OPRQ looks like this, and the straight line is passing through the point 2 3, and our interest is to find the locus of R. Therefore, take R as locus point x1 y1. Then the P coordinates will be x1 0 and the Q coordinates will be 0 y1, and the equation of PQ in intercept form is given by x by x1 plus y by y1 is 1, and this straight line is given to be passing through 2 3. Therefore, you substitute 2 3 here, giving you 2 by x1 plus 3 by y1 is 1. Therefore, the locus of R is 2 by x plus 3 by y 1. It simplifies to 3x plus 2y is xy. Therefore, option 2 is the correct answer. Now we will discuss question 15. A is sum of first 20 terms and B is sum of first 40 terms of the series 1 square plus 2 into 2 square plus 3 square plus 2 into 4 square plus 5 square plus 2 into 6 square and so on, and B minus 2A is given to be 100 lambda. Then what is lambda equal to? And the given series can be rewritten as 1 square plus 3 square plus 5 square plus 7 square etc. 2n minus 1 whole square plus 2 into 2 square plus 2 into 4 square etc. 2 into 2n square if we consider 2n terms. So, that is why we say consider 2n terms of the series. This can be simplified by noting that 1 square, we write 2 into 2 square as 2 square plus 2 square plus 3 square written as it is, 2 into 4 square as 4 square plus 4 square plus 5 square as it is plus 6 square plus 6 square etc. etc. Then we have the last two terms 2n minus 1 whole square plus 2 into 2n whole square, and this 2 into 2n whole square can also be written as 2n whole square plus 2n whole square. And now we can see by regrouping the terms we get 1 square plus 2 square plus 3 square etc. up to 2n whole square, and the remaining terms can be simplified by taking 2 square common from 2 square, 4 square, 6 square etc. 2n whole square, that is you get 2 square into 1 square plus 2 square etc. up to n square, and this is sum of squares of first 2n natural numbers, and this is sum of squares of first n natural numbers. Therefore we will be using the formula 2n into 2n plus 1 into 4n plus 1 by 6, plus this will be 4 into sum of squares of first n natural numbers, n into n plus 1 into 2n plus 1 by 6, and if you simplify this you get the sum given by n into 2n plus 1 whole square. So this is sum of first 2n terms. Therefore if you want to get sum of first 20 terms, namely a, we have to put n 10, and that will give you 10 into 21 whole square, and if you want to get the sum of first 40 terms, you put n is equal to 20, giving you 20 into 41 square, and now we can calculate b minus 2a. So therefore you get b minus 2a given to be 100 lambda, and from here by substituting b and a we get 20 into 41 square minus 21 square is 100 lambda, and calculating lambda will give us lambda is equal to 248. We now discuss a question 50. A is sum of first 20 terms, b is sum of first 40 terms of a series 1 square plus 2 into 2 square plus 3 square plus 2 into 4 square plus 5 square plus 2 into 6 square and so on. Given b minus 2a is 100 lambda, then what is lambda? First we rearrange the given series in this form: 1 square plus 3 square plus 5 square plus 7 square etc. 2n minus 1 whole square. The remaining terms can be regrouped: 2 into 2 square plus 2 into 4 square etc. up to 2 into 2n square. And again rearranging in this manner: 1 square plus 2 square, the 2 into 2 square can be written as 2 square plus 2 square, keeping 3 square as it is, 2 into 4 square as 4 square plus 4 square, 5 square as it is, and so on. The last terms can be written 2n whole square, 2n whole square, and regrouping the terms by writing 1 square, 2 square, 3 square, 4 square up to 2n square, and in the remaining terms 2 square, 4 square, 6 square etc. 2n whole square. By taking 2 square common we get this term, and this being the sum of first 2n natural number squares, and this being the sum of first n natural number squares, by using appropriate formula we get 2n here, 2n plus 1, 4n plus 1 by 6, and this will be 4 into n plus 1 into 2n plus 1 by 6. By simplifying this we get the sum n into 2n plus 1 whole square, and to get the sum of first 20 terms we put n 10 here, giving you a as 10 into 21 square, and to get the sum of first 40 terms we put n 20, giving you b as 20 into 41 square. So we get b minus 2a is equal to 100 as 20 into 41 square minus 21 square is 100 lambda. So we get lambda 248, giving you option A as, that is 1 as the solution. We now discuss question 51. The curves y square is equal to 6x, 9x square plus by square is equal to 16. They intersect each other at right angles, then the value of b is, whenever two curves intersect at the point of intersection, product of the slopes must be -1, and slopes here are given by values of dy by dx. Therefore, for y square is equal to 6x, we write dy by dx, so it is given by 3 by y, and for the curve 9x square plus by square is equal to 16, we write dy by dx given by minus 9x by by, and at the point where they meet, the product of dy by dx for the first curve, for the second curve it must be -1, so therefore we get 3 by y into minus 9x by by must be equal to -1, giving you 27x is equal to by square. But we also know y square is 6x, therefore it becomes b into 6x, giving you 6b is 27, hence b is 9 by 2, and therefore the option in this case will be option 3. Coming to 52nd question, orthocenter centroid of a triangle are A -3 5 and B 3 3 respectively, and C is circumcenter of the triangle. The radius of the circle having the line segment AC as diameter, and here we know that the circumcenter, namely C, the centroid, namely B, and the orthocenter, in this case it is A. That means the circumcenter C and the centroid, namely B, and the orthocenter A, they will always be collinear. We now discuss question 52. Orthocenter centroid of a triangle are A -3 5, B 3 3, C is circumcenter, radius of the circle having line segment AC as diameter. We know a property that the line joining orthocenter and circumcenter is divided by the centroid in the ratio 2:1. Therefore, by section formula 2C plus A must be equal to 3B. So, substituting the coordinates gives 2 times AB plus -3 5 is 9 9. So, therefore, we have 2 times AB is 12 4, therefore, AB comes out to be 6 2, and this is nothing but circumcenter. And we also know what is orthocenter. A is -3 5, therefore, we can calculate AC, it is given by root of 90, and this simplifies to 3 root 10, but this is diameter. Therefore, the radius is given by AC by 2, 3 root 10 by 2, it simplifies to 3 into root of 5 by 2, and therefore the correct option is option 2. We now discuss question 53. SC is given to be the set of all t in real numbers such that f of x is mod x minus pi into e power mod x minus 1 into sine of mod x is not differentiable at t. Then the set S is equal to, and because the function is involving mod x and mod x minus pi, the expected points of non-differentiability are 0 and pi. So that is why we calculate the derivative by definition at 0 and pi, namely f of x derivative at 0, f dash 0, by definition it is limit of f of x minus f of 0 by x minus 0 as x tends to 0, and for the function under consideration, if you calculate, it comes out to be limit x tending to 0 mod x minus pi into e power mod x minus 1 into sine of mod x, and f of 0 is clearly 0 by x, and this value can be rewritten like this: limit x tending to 0 mod of x minus pi into e power mod x minus 1 into sine of mod x by x. As x tends to 0, this value will be pi, and this will be 0, and this will be, the right limit can be plus 1 and the left limit will be minus 1. So that means it is plus or minus 1, in which case this will be 0. So therefore here f dash 0 has become 0, therefore fx is differentiable at x is equal to 0. In the same way, if you calculate f dash pi, by definition it is limit x tending to 0 f of x minus f of pi by x minus pi, and this will be limit x tending to pi, f of x is again mod x minus pi into e power mod x minus 1 into sine of mod x minus f of pi, because of mod x minus pi will again become 0 by x minus pi, and this will be again limit x tending to pi mod x minus pi by x minus pi into e power mod x minus 1 into sine of mod x. When x tends to pi, this value will be either plus or minus 1 depending on the right or left approach, and this will be e power pi minus 1, but this will be sine mod pi, which will be 0, and that is why this limit will be 0. Therefore f dash pi is also 0. Therefore at the expected points where we have the function non-differentiable, namely at 0 and pi, it is becoming differentiable. Therefore there are no points where this function is not differentiable, and therefore the correct option will be no points where it is not differentiable. Hence the correct option will be option 4, that means empty set. Therefore the answer is option 4. We now discuss question 54. Given the determinant x minus 4, 2x, 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 x minus 4, 2x, 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 x minus 4 is equal to a plus bx into x minus a whole square, we are asked to write what is the ordered pair AB equals to. For the left side determinant, we can now apply either row or column operations. For example, if we apply the row operation R1 plus R2 plus R3 becoming row 1 will give us, so 2x plus x minus 4, 5x minus 4, here also 5x minus 4, here also 5x minus 4, the remaining 2 rows remain same, 2x, 2x, x minus 4, and we can now take 5x minus 4 common, giving you the determinant 1, 1, 1, 2x, x minus 4, 2x, and 2x, 2x, x minus 4. We now do the standard column operations, namely C2 minus C1 changes to C2, C3 minus C1 changes to C3, and this now becomes 5x minus 4 into the determinant. The first column remains same, 1, 2x, 2x. The second column becomes 0, minus of x plus 4, 0. The third column becomes 0, 0, minus of x plus 4. So if you now expand by using the first row, we get 5x minus 4 into x plus 4 whole square. You compare this with a plus bx and x minus a whole square. The comparison will give us b value as 5 and a value as minus 4. Therefore, the ordered pair AB is given by minus 4, 5, giving you option 2 as correct option. We now discuss question 55. We are asked to simplify the Boolean expression not of P or Q or not P and Q. What is it equivalent to? For that we can use first De Morgan's law. This is identically the same as not P and not Q or not P and Q, and we can now use distributive laws again. So this will be equivalent to not P or Q and not Q. We discussed question number 55. We are asked to simplify the Boolean expression not of P or Q or not P and Q. To simplify this, first we apply De Morgan's law. Not of P or Q is not P and not Q or not P and Q, and by distributive law it simplifies to not P and Q or not Q, and Q or not Q is always a tautology. Therefore this is not P and true, and therefore this simplifies to not P. Therefore the correct option is option 4.
56 question. What they have given is a linear system of equations. X plus ky plus 3z is 0, 3x plus ky minus 2z equal to 0, 2x plus 4y minus 3z equal to 0. They are saying system has non-zero solution x comma y comma z. So immediately we know determinant should be equal to 0. So 1k3, 3k minus 2, 2, 4 minus 3 equal to 0. Solving will get k equal to 11. Now in order to give the value of x z by y square, one way we can actually solve the system with k equal to 11. Alternatively, since these are three planes passing through origin, we can find the line of intersection, and we know drs of line of intersection directly is given by cross product of any two normals among the three planes. Let us say n1 is normal to first plane, n2 is normal to second plane. So n1 cross n2, if you find ijk and 1k, k is 11 and 3, 11 minus 2, then we get minus 55i plus 11j minus 22k. If you pull out minus 11, right, so drs we can take them as 5 minus 1
and 2. Therefore, line of intersection is directly given by x by 5 equal to y by minus 1 equal to z by 2, right. Therefore, we want xz by y square, that is equal to x by y into z by y, but x by y you can see minus 5 into z by y you can see minus 2, that is equal to 10. Therefore, option 1 is correct. 57th question, s equal to x belongs to R such that x greater than or equal to 0 and 2 mod root x minus 3 plus root x into root x minus 6 plus 6 equal to 0. Now, this set will contain dash, how many elements, right. So, obviously, we need to solve this equation. The simplest way, as you can see, is we will put the whole thing root x minus 3 equal to t. So, if you put t equal to root x minus 3, right. So, what will happen, the equation become 2 mod t. Now, root x become t plus 3, root x minus 6 become t minus 3 plus 6 equal to 0. Simplifying, we get t square plus 2 mod t minus 3 equal to 0. Now, as you can see, this is a quadratic equation in mod t whose roots are mod t equal to minus b plus minus root b square minus 4ac by 2a, that is equal to root 4, right. So, minus 1 plus minus 2. Therefore, we get mod t equal to 1 comma minus 3. Since mod t is non-negative, this is gone. So, what we have is mod t is 1 or t equal to plus minus 1. But what is t? Root x minus 3. Therefore, root x equal to 4 comma 2. Therefore, x equal to 16 comma 4. Therefore, this set will have exactly 2 elements and hence option 2 is correct, right. Next question, question number 58. If the tangent at 1 comma 7 to the curve x square equal to y minus 6 is a tangent to another circle, right, it touches this circle, that is what they have given, x square plus y square plus 16x plus 12y plus c equal to 0, right. If you remember the standard tangent equation for this parabola, we can use it. If not, no need to worry. The point of contact has been given to you as 1 comma 7. What we will do is differentiate this, you get 2x equal to y dash, that is equal to 2 at x equal to 1. Therefore, tangent equation is, tangent at 1 comma 7 is y minus 7 equal to 2 into x minus 1 or y equal to 2x plus 5, right. Now, this line is tangent to this circle whose center is minus 8 minus 6 and radius you can see under root g square plus f square minus c, that is 100 minus c. Now, since a line is tangent to this circle, obviously you know the perpendicular distance from center to the line should be equal to radius. So, if we apply that, perpendicular distance from center to line is equal to, right, substitute 2x minus y plus 5 by root over 2 square plus 1 square mod, that should be radius. So, if we simplify this, what we will get, minus 16 minus 10 5 by root 5, that is equal to root 5, that is equal to root 100 minus c. So, you get c equal to 95, c equal to 95, that is option 3. Okay. Next one, question number 59, that is a differential equation question, simple and straightforward, linear differential equation, right. Sin x dy by dx plus y cos x equal to 4x. What we can do, divide by sin x, dy by dx plus y into cos x by sin x equal to 4x by sin x. So, this is clearly linear differential equation. Okay, the integrating factor is given by e power integral cos x by sin x into dx, that is equal to e power ln sin x, that is equal to sin x. Therefore, the solution is given by y into if equal to the other side function into if dx, right, that is equal to 2x square plus c. In order to find the value of c, he has given an initial condition, that is y of pi by 2 equal to 0. That means we have to put x equal to pi by 2, y should be 0. So 0 equal to 2 into x square, pi square by 4 plus c. So c will be minus pi square by 2. Therefore, y sin x equal to 2 into x square minus pi square by 2. That is the solution, but what he wants is y of pi by 6. So what we will do? Put x equal to pi by 6 in this equation, say equation 1, right. So put x equal to pi by 6 in this, then y into sin 30 1 by 2 equal to 2x square pi square by 36 into 2 18 minus pi square by 2, right. So that is minus 8 by 18 pi square. So y equal to minus 8 by 9 pi square, right. So minus 8 by 9 pi square, that is in option 2. Okay. Next one, question number 60. L1 is the line of intersection of 2x minus 2y plus 3z minus 2 equal to 0 and x minus y plus z plus 1 equal to 0. L2 is the line of intersection of x plus 2y minus z minus 3 equal to 0, 3x minus y plus 2z minus 1 equal to 0. What we want is the distance of origin from the plane containing both the lines L1 and L2. We can do one smart method here, right. So we see there are two planes here, there are two planes and there is line of intersection, there is one more set of two planes, line of intersection. We want this plane containing this line of intersection, this line of intersection, right. So what we can do, we can assume our required plane as L1 plus 2x minus 2y plus 3z minus 2 plus lambda into x minus y plus z plus 1 equal to 0, using the concept of family of planes passing through intersection of pi 1 and pi 2. In the same way, the same plane, required plane, can be assumed as x plus 2y minus z minus 3 plus mu into, for example, 3x minus y plus 2z minus 1 equal to 0, right. But we are looking for same plane, which means equations 1 and 2 must be identical, 1 and 2 must be identical, 1 and 2 must be identical equations representing same plane. Therefore, we will compare the quotient of x, y, z and the constant. Quotient of x, if you see, 2 plus lambda in this equation, and here it would be 1 plus 3 mu, that should be equal to quotient of y here minus 2 minus lambda by 2 minus mu, z quotient if you see 3 plus lambda divided by minus 1 plus 2 mu, and that should be equal to the constant minus 2 plus lambda divided by minus 3 minus mu. So we have got set of equations representing the variables lambda and mu. So if we cross multiply each two equations and solve, we get lambda equal to 5, mu equal to minus 3 by 2, right. Take lambda equal to 5 and put it in first equation. So required plane would be equal to 7x minus 7y plus 8z plus 3 equal to 0, right. So this is our plane. What he wants now is the distance of origin to this plane. We know distance of origin, perpendicular distance from origin to plane is equal to mod of constant term divided by root over a square plus b square plus c square, right. So, if you apply that, what will get 3 divided by root over 7 square plus 7 square plus 8 square, that is 3 by root 192, which is 1 by root 18, right. That is 1 by 3 root 2 upon simplification. So, we have that in option 1, right. So, option 1 is correct.